This is how a potato farmer is going to split up some land for future generations. So you can imagine a big bit of land and we want to split it. How are we going to split it up? Well, this is how it's done. Now you've got 2 bits of land. Now you've got 4 bits of land. What's the process of how this is happening? Can you predict what is going to happen next? So ask your kids to just take a moment and make some hypotheses. How is this working? We want more wrong hypotheses than right hypotheses whenever we're doing these activities. Okay, it's great to be wrong and to have the liberation in your class to be wrong. Okay, so here we're going. Now we've got a whole bunch of farms. Okay, so let's now look at how this actually worked. So you take as large a circle as you possibly can in your existing farmlands. So here we only have 1 bit of big farmland, so we take the biggest circle possible. Then we look at the points that are touching the edges. This circle is touching the edges on 3 points, and we connect up the 2 of those points that are furthest away from each other. Okay, we remove the circle and we've now got 2 bits of land. We're going to add a circle to each one of those, as big a circle as possible. Okay, let's see. Okay, those are the biggest circles possible in each of those bits of land. Again, where is the circle on the left touching? Okay, it's touching the edge of its region in 3 positions. Which 2 of those are furthest apart? Same with the circle on the right. Okay, we now have 4 regions. Each time you might have figured out the number of regions is doubling. So again, we're going to be adding the biggest possible circle in each one of our regions, looking where the edges are touching, and then choosing the furthest 2 of those for each circle. Okay, so that's how we are generating this beautiful, beautiful, you can imagine that this is farmland. Yeah, so this is the yellow algorithm. Next, let's go on to the blue. Here we have another idea. This woman has a different idea about how to split up farmland. So we start with the same beautiful big bit of land, and you guys have to figure out the rules for how she's splitting it up. So first of all, there's a lot more little pieces here. So it got split up really quickly. So let's see. We start off the same thing. We start off with the same big circle. But this time, instead of only connecting the furthest 2 of the points, we connect all of the points that are touching. So that circle is touching in 3 points. We connect all of those points to the center of the circle. There we go. Now we're going to do this again. Okay, so we're going to remove that circle. Now we're going to add the biggest possible circle to each one of these regions. There we go. And you notice that 2 of those circles, the ones on the right, they are touching in 4 spots. So we're going to get 4 edges into the center of those circles. Okay, the one on the left only touched 3 times in its region. Okay, and we continue that, and that is the crazy, and you can see it's quite different from the other one, but beautiful as well. Next, we're going to deal with this solution. Here is a woman who has a different idea about how to split up farmland. So here, figure out how she's doing it. So how is she doing it? Let's go back to the first big bit of land. Again, she finds the biggest circle, but then she finds the second biggest circle. She draws a line between the centers of those two circles and keeps on going and as far as she can. So that splits the land into two. She removes the circles, does it again, adds the biggest possible circle in each region, then adds the second biggest circle in each region. Now it draws a line through for each of those regions, those two circles, draws a line through their centers and keeps on going. Okay, and there we go. We have 4 circles in 4 different regions. We're going to add the second biggest circle in each region now. And we draw a line through the center, and there we go. So this turns out to be a very different type of arrangement. And you can see these are going to become long, skinny plots of potatoes. You can imagine maybe planting a single row of potatoes in a big long line in these farms. Okay, last one. Okay, this is this woman has a totally different idea. Here is her red big bit of farmland. What are the rules? You can halt the video at any time during this process if you want to try to figure out what's going to happen next. Okay, so there is a point midway through this algorithm. What are the rules here? Well, you choose the biggest circle again, and then we find of all of the vertices in that region, we find the vertex that is closest to the center, and we draw a line connecting the two. Then we find the second closest vertex and draw a line to that. Okay, now we have 2 regions. In this algorithm, we only choose the biggest circle in the entire space. Okay, so yeah, we've got 2 different regions here. We don't care. We're just finding the biggest circle that exists in either one of these regions. And that's it. That's the biggest possible circle. And which do you expect? Which line do you expect first? Well, of all of the vertices, the one that's closest is that one, that pointy one. And the second closest, I think, is maybe the far left one. There we go. Okay, remove the circle, add again. That's the biggest circle possible in any of these regions. That's the closest vertex. What's the second closest vertex? Okay, right in the corner. Next one, this is the biggest circle. And we can connect to that one and to that one. And this produces a very weird looking set of farms. You can imagine that this would be rather difficult to put into practice, building triangular farm plots. So I'm not saying that these are practical solutions to any problem, but this is a mini mathematical universe. The point here is inductive problem solving. Inductive problem solving is wildly underappreciated in current curricula around the world. So here we go, a bit of inductive problem solving for your classroom.